Hello and welcome to Maths with Raz. I am your host, Mr. Raz. So today we're going to do some year 12 stroke year 13 trigonometric identities involving the reciprocal trig functions. This is video 1. Video 2 will then have examples only, and potentially that will link to video 3 as well. So this is the lesson video. So let's firstly we're going to start with some proofs. So the first thing is proving that one of the first things you could have learned in year 12 was about what tan theta is and how that is derived. So often it will be given as a show that. So I used to love these. I've mentioned in the previous video, show that's the questions for trig functions where I really started to like maths. So if you recall from GCSE, I've got the three identities at the top that we know what sine is, we know tan, and we know cos. Yeah, we want to prove the left equals the right. So we just consider the left-hand side, we ignore the right-hand side, and we will work towards it. So essentially, we've just been given the answer, and we have to display all our workings. So first we sub in, we make the replacement that sine is opposite over hypotenuse and cos is adjacent over hypotenuse. How do we divide fractions? That's right, yeah. We leave exchange term, and we get this. Are there any factors that cancel? Well, yeah, if you look at the screen, you can see that the hypotenuse cancels. And we're left with opposite over adjacent. If we look up to the top of the screen, we have tan is opposite over adjacent. So we end up with the right-hand side of the equation as required. Yeah, and that's it. That is what we do in show that. Love it. Love these things. Let's just go to the next one. This is a harder one. This is a harder one for you to prove yourself. So the first time you do maths, first time you do this topic, to prove this with very little support is quite difficult. Obviously, once you've seen it, it's a little bit easier. So we draw the four quadrants, and we draw the four quadrants, and then we put in it the unit circle. So unit circle is one where the radius is 1. Yeah, hence 1 unit. It's called the unit circle. So if the radius is 1, you can see I've constructed a right angle triangle that will have a hypotenuse of 1. So I'm going to label I've given an angle theta. So relative to the angle, I'm going to label an x and a y. Yeah. So using SOHCAHTOA, we can describe x and we can describe y. Yeah. So first I'm going to describe y. So we have sine theta is opposite over hypotenuse. So that will be y over 1. And obviously the y, the 1 dissolves. So we just got sine theta equals y. Similarly, we can do it for x, and we have the adjacent and the hypotenuse. And again, the hypotenuse is 1, so we just end up with x equals cos theta. Yeah, so I've just subbed the numbers in, and if you divide by 1, it just disappears. So I've described y in terms of sine theta, and I've described x in terms of sine theta. Sorry, cos theta. So now if I use Pythagoras' theorem, which is the hints in the top left-hand corner, it then follows that we have the diagonal squared equals the sum of the squares of the shorter sides. So we have cos theta squared plus sine theta squared equals 1. Lo and behold, we have proved the equation. Yeah? How can you not love these? Yeah? Beautiful. Beautiful maths. So, no proofs here. Learn these, yeah? Much like when you're younger, you learn your left and right. I learned it whilst doing karate. Yeah. And you had to learn one, because if you know left, you know right by accident, don't you? So here you just need to learn these, yeah. They are definitions. There's no like real thought behind it, no proof. So it is 1 over cos is sec, 1 over sine is cosec, 1 over tan is cot. Yeah. You know that as you write this down, I'll ramble on a little bit. So we know that cos is short for cosines. sin is sine, and tan is tangent. Yeah, I don't know why I just said sin. That is my sin. I hate saying that word. Yeah, once. Why would you abbreviate one syllable to one syllable? I don't know. Sec is short for secant. Cosec is short for cosecant. Cot is short for cotangent. Yeah, I've said it many times before. I'm a mathematician, not an Englematician. So I don't really care about the words. Those are the identities you need to know, and I'll be using the abbreviations. So from that, we can prove more identities. So I urge you to pause the video right now and give it a go. Whilst you do that, I'm going to flex some of my series skills. You can have till the end of the countdown video to do these. Yeah. Hey Siri, can you play the countdown theme tune, please?
Okay, playing countdown theme by the Blue Keys.
So let's do the one on the left first. I gave you no support, so if you got these right, well done. The hint is divide by cos squared theta. So divide everything by cos squared. So if you didn't do that, I'm not going to play the theme tune again. And try dividing the other one by sine squared. Yeah, pause me now and give it a go. You'll learn more that way. Yeah, remember you learn from your mistakes in life too. So, cos over cos, cos squared over cos. If I deal with the left-hand side, cos squared over cos squared is 1. Sine squared over cos squared is tan. And 1 over cos squared is, I don't remember. Hopefully you've written it down. You're just looking at your page. If not, I've got you back. Yeah? So 1 over cos is sec. Therefore, 1 over cos squared is, you got it, sec squared. Yeah, so simple as that. So we end up with 1 plus tan squared, theta, equals sec squared theta. So if we do the right-hand side, similar principles, yeah, we get to there. Cos over sine squared is the reciprocal of tan. Yeah, we know that tan is sine over cos. So hopefully you understand that cos over sine is the reciprocal of that. And what is the reciprocal of tan? Cotan, exactly, cotangent, cot. And 1 over sine is cosec, yeah? No excuses for not getting that one because it's on the screen. So if we just look at it now, we have 1 plus cot squared equals cosec squared theta. Yeah? So those are the proofs. You could be asked to do it. Yeah? You should be pleading you get asked to do it because it's easy marks. You've been asked in an exam to show something. So in other words, they give you the answer. You get it wrong, you can correct yourself. Yeah? How can you not love a show that? So that leads us to us learning these identities, yeah? So I'd advise you, you have to memorize the one in green, yeah? You have to memorize the one in pink. I then wouldn't memorize the other two that are on the screen. I would always just prove it. Yeah, I tend to find when you don't make an effort to memorize stuff because you know you back your techers, yeah, your maths techers. If you back them, you know that you can prove it and discover the other identities. You'll end up just learning them anyway. So whilst you're jotting that down, hopefully, I'll ramble on. It's important you can rearrange the pink one to create 2 new identities. Some of you may have done that in the last task when I said, oh, what are the other 2 identities? And you may have just written 1 minus sine squared equals cos squared. You might have written 1 minus cos squared equals sine squared, just from rearranging this one in pink. Yeah? I don't count those as new identities. They're just, you've just rearranged something. Yeah? But it's good to know that, because we will need those in the example videos. Well, so in the next video. And maybe later in this one. Hey guys, I'm just going to interrupt. Let's take a break there, and I'll see you in part 2.